Welcome to this explainer. Today, we're taking a literal deep dive into an environment that's right here on Earth, but honestly, it feels entirely alien. We're going to explore the sheer scale, the crushing depths, and the profound mysteries of our oceans. It's a massive, super dangerous, and deeply mysterious world. It sustained life for billions of years, and yet it remains one of the least understood frontiers we have. So strap in, because we're going straight into the abyss.
Okay, let's dive into this. 71%. Think about that. If you look at a globe, the dominant color isn't green or brown. It's just vast, uninterrupted blue. 71% of our entire planet's surface is completely covered by this massive body of salt water. I mean, we call it Earth, but really, it's planet ocean. And when we talk about all the water on our planet, a staggering 97% of it is held right here in these massive oceans. That means all the fresh water we drink, the lakes, the rivers, the glaciers, that makes up just a tiny, fragile fraction of our water supply. The overwhelming majority of the life-giving liquid on our world is salt water, locked away in the deep.
Section 1. Introduction and Origins. How the oceans formed.
To actually understand our oceans, we have to rewind the clock billions of years. Science tells us this absolutely incredible story of planetary evolution. Step 1. As the molten Earth began to cool down, massive volcanoes continuously erupting, blasting colossal amounts of steam into the atmosphere. Step 2. As the atmosphere cooled even further, that volcanic steam condensed and turned into rain. And step 3, it rained, literally for millions of years. This relentless downpour gathered in the Earth's lowest basins, gradually filling them up to form the primitive oceans. Oh, and fascinatingly, many scientists theorize that icy comets bombarding the early Earth might have actually delivered a huge chunk of this water directly from deep space. Fast forward to today, and those ancient basins form the 5 major oceans we map out across the globe. You've got the Atlantic, the Indian, the Arctic, and the newly officially recognized Southern Ocean. But the undisputed king here is the Pacific Ocean. It's not just the largest body of water on Earth by a massive margin, it's also the deepest, hiding extremes that we're only just beginning to wrap our heads around. Let's move to and see how this builds in Section 2, Ocean Depth and Zones, Descending into the Abyss. Just looking at the surface tells us almost nothing about the sheer volume underneath. The average ocean depth is about 3.7 kilometers, but it hides some terrifyingly deep trenches. To put this extreme depth into perspective, let's look at the Mariana Trench in the Pacific. It holds the deepest known point on Earth, the Challenger Deep, plunging down nearly 11 kilometers. To give you a sense of scale, if you were to take Mount Everest, the tallest point on land, and drop it directly into the Challenger Deep, the entire mountain would completely disappear under the surface. You'd still have over a mile of dark water rolling above its peak. As we descend those 11 kilometers, the ocean drastically changes. We start up at the sunlight zone, where light penetrates and things like plants, dolphins, and sharks thrive. Further down is the twilight zone. Only faint light reaches here, and honestly, life starts to look a bit strange. Below that is the midnight zone, which is absolute pitch blackness. Then comes the abyss, an area defined by freezing temperatures and crushing forces. And finally, we reach the Hadal zone. Named after the Greek underworld, it's the deepest, most dangerous trench environment on Earth. And this brilliantly illustrates why the deeper you go, the more dangerous it gets. It all comes down to the physics of pressure. The formula P equals rho GH explains exactly how fluid pressure works. Basically, in the ocean, for every 10 meters you go down, the weight of the water above you increases the pressure by 1 full atmosphere. Down in the deepest trenches, the physical pressure is thousands of times greater than at the surface. It's an incredibly extreme, deadly environment that will instantly crush anything that isn't perfectly adapted or heavily engineered to survive it. Section 3. Waves, Tides, and Storms, the dynamic movement of water. Now, the ocean is literally never still, and everyday waves driven by wind are just part of the story. Enter the ultimate cheat code of the universe: gravity. This formula dictates how mass attracts mass, so even though the moon is hundreds of thousands of miles away, its gravitational pull reaches out and physically pulls the Earth's massive oceans toward it. As the Earth rotates, this pull shifts, creating that continuous rhythmic rise and fall of water levels that we experience locally as high and low ocean tides. But, as you probably know, not all movement is rhythmic or gentle. When immense energy is violently released underwater, usually through a massive earthquake or a volcanic eruption,
It displaces a staggering amount of water all at once. This creates a tsunami. And here's the really scary part. The energy wave of a tsunami traveling through the deep ocean can actually match or even exceed the cruising speed of a commercial airplane. It is a terrifying display of raw, destructive power. The ocean's movement also controls the sky above us. It basically acts as Earth's master climate control system. It absorbs massive amounts of solar heat, completely shaping global wind patterns and creating the rain that sustains all of us on land. However, this system definitely has a volatile side. When ocean waters get unusually warm, that massive thermal energy fuels highly destructive storms like hurricanes and cyclones. Section 4. Ocean Mysteries and Creatures, the Unexplained and the Alien. Now, what's really interesting about this phenomenon is what happens down in the dark, where the ocean feels undeniably alien. To survive pitch-black darkness in the midnight zone, creatures like the anglerfish, various jellyfish, and the lanternfish use a process called bioluminescence. Because sunlight literally cannot reach them, they've evolved to become their own light sources. They glow in the dark to hunt prey, distract predators, or communicate in the absolute void. It's like a sci-fi movie down there. The ocean also holds geographical mysteries. None is more famous than the Bermuda Triangle, a region noted for the disappearances of ships and aircraft over the years. Now, while pop culture loves a good ghost story, oceanographers impartially look at the documented scientific factors. Theories range from severe, sudden bad weather to strange local magnetic changes that throw off compasses, simple tragic human error, or even massive methane gas eruptions from the ocean floor that can instantly destroy a ship's buoyancy. Section 5. Humans, Ocean, and Dangers. Survival in an Alien World. Biologically speaking, we have absolutely no business being in the deep sea. To explore it, we have to rely on heavy engineering. Submarines are basically self-contained ecosystems. They use complex oxygen generation systems, advanced water purification, and heavily armored hulls with precise pressure control mechanisms. For individuals actually venturing outside a sub, deep-sea divers require highly specialized suits. These things function like wearable spacecraft, protecting them from the freezing cold, supplying continuous oxygen, and shielding their bodies from being crushed by the immense water pressure. Even though we need all this advanced tech to survive deep inside it, the ocean's most famous feature is easily visible from space: its color. So why is it so perfectly blue? Well, it's just simple physics. When sunlight hits the water molecules absorb colors in the red part of the light spectrum. The blue light, however, doesn't get absorbed. It's reflected right back out to our eyes, giving the ocean its vast signature hue. But while light really struggles in water, sound absolutely thrives. Sound waves actually travel much faster and much further through water than they do through the air. This fundamental acoustic property is heavily utilized. It's exactly how massive whales communicate over hundreds of miles, and it's how human submarines use sonar systems to ping their surroundings. That's how they safely navigate the pitch-black depths where normal cameras are completely useless. So the crucial point is this: despite its extreme dangers, humanity absolutely depends on the ocean for survival. It provides a massive portion of the breathable oxygen we need. It's a critical global food supply. It provides the international trade routes that literally run our modern economy. It maintains the delicate climate balance of Earth. Plus, marine biology is constantly discovering new organisms that lead to huge breakthrough medicinal discoveries. We simply cannot live without a healthy ocean. Yet, for all its importance, consider this stunning contrast. We have intricately mapped the surface of the moon, a celestial body hundreds of thousands of miles away in space. But back here at home, huge swaths of our deep ocean floor remain completely unexplored and uncharted by science. Marine biologists and oceanographers are truly just scratching the surface of what's actually down there. Which leaves us with a profound question. Will we ever fully understand the largest, most vital, and most mysterious part of our very own home planet? Every dive deeper brings new questions, new creatures, and new wonders. The ocean is vast, and the journey to uncover its secrets is really only just beginning. Thank you for joining me on this explainer. Keep exploring, keep questioning, and I'll see you next time.